Hello students, and welcome to the continuing lesson on the smarter robot or the new robot class. And in this video I'm going to show you how to actually extend the robot class and do something some more powerful things with it. Okay. So here I've created a new class called smarter bot and extends robot, not your robot. And then all I've done here is built a constructor, and just to remind you that we have this really nice documentation. So I'm going to write up, and we have a bunch of predicates here, some functions that indicate certain states of the robot. And I'm going to write a function here called face north. Okay. So this is not a yes/no type of function. It's not a predicate, it's an action, right? So it's going to force the robot to face north. Now, however, in order to know that we're facing north, you have to know in order to make us face north, you have to know where you're facing to begin with. So we can do this with a bunch of conditionals. So we can say if is facing east, then turn left. Okay. Now note here, I'm not doing carel.turn left or robot.turn left because in this code I am the robot. We are actually inside, we're modifying the blueprint of the robot. So we don't have to specify it. If you wanted to, you could say this, which is, we talked about before, it's referring to yourself. But for the sake of brevity, we'll omit that for now. Else if is facing let's say west. Now if it's facing west, then we need to make it turn right. Else if is facing south, then we need to make it turn around. Else, and I'm just going to make a comment here, if it's not facing east and it's not facing west and it's not facing south, then it must already be facing north. Okay. Then do nothing. Now in Java, if you actually want to do nothing inside of an if or else condition, you have to give like a blank semicolon. Most of the time you can just omit this, but I like to add it just to remind us that this is the default case and there's nothing for us to do. Okay, so we're going to compile, and you can see here that I have a bunch of errors, mostly that it doesn't recognize this has a problem with this line is facing east. So let me check my documentation. Because the name of the function does not include the word is, I need to fix that. So it's just facing east, facing west, facing south, save and compile. And now I have a different error that that turn right doesn't exist. Okay? And so as smart as robot is, it still doesn't know how to turn right. So we can just program that in here real fast. Turn right is just turn left 3 times. Okay, get my formatting in order, and then we're probably gonna end up with an error for turn around since that doesn't exist either, so I'll add that here. And turning around is just turn left twice. Okay. Compile, and there we go. Okay. Now to test this, I'm going to go into my main file and make a world, and then make my own robot. And this time it's called smarter bot. We'll call this Wally. Let's make it a little higher. 3,1 directions dot south, for example, 0. All right, and then we can try, and we can just say Wally dot face north and see if this works. So there it goes. It compiles, and the screen should pop up any minute. There's Wally initially facing south, and now it faces north. So that's one test. We can see that our function clearly works. Okay. Now we can also add additional features to this. So let's write a new predicate. All right. Let's write something called. I'm going to start it up here. Boolean. I'm going to write a new predicate. We'll call it back is blocked. So we want to. This thing will determine if there is a wall behind us. Now, this is a predicate, so it should do a lot of things, but mainly it's going to answer a yes-no question. So we're going to call it public boolean. The function is going to be named back is blocked. And what we need to do now is turn around. So think about this. The robot has to turn around and then check. So I'll write some code here. Check if front is blocked, and then return true or false. Okay. So let's do that. So it's turned around. If front is clear. Remember, we don't have a front is blocked function. All we have is a front is clear function. So we're going to use this Java syntax called the not operator. So if not front is clear, so this is saying this is the same thing as checking if the front of it is blocked. If it's this is if it's blocked, then we are going to return true. Okay. Otherwise, return false. So now I can go back. This is the way that I'm going to test this. Is let's see. I'm going to have this guy face the east to start with. And I'm going to say some condition. If Wally.back is blocked, system.out.println back is blocked. Compile and run. So here he goes, he turns around, checks, oh, that's blocked, and then he's going to print out the statement, see, back is blocked. Now, if you look at this, there's actually a problem with this robot, is that when you ask it a question, you change the state of the robot. Right? So whatever direction it was facing before, it should face that direction afterwards. It should simply ask a question. Right? It may need to turn around, but it should return back to its original position. So now, you might want to be tempted to say, oh, let's just add a line at the end of it. Let's just make it turn around. Okay, make the robot. Since we turn around at the beginning, we're going to make the robot turn around at the end. Make the robot face the original position. Well, this is going to cause a slightly different problem, and you're going to get a compilation error that says unreachable statement. Okay, so what that means is that no matter what happens in your code, you're never ever going to reach this statement that says turn around, because you already returned. Okay, so whenever you return from a function, that's the last statement in the function. So the only way to get around that problem, there's several ways to get around it, is to add it to the if, turn around, and also when you are when both the case that you're returning true and you're returning false, you have to you have to make sure that it turns around first. So we can compile this, go back into the main, and then compile and run. My compiler here is taking its sweet time. But let's see, should be done, and I should be able to run. So we can see, let's see, let it load up. There it is. So it's going to turn around and check, and the nice thing is that it's going to come back to where it started from. Okay, that's a basic rule of programming, is that when you go and check for something to be true or false, after you're done, you should return it to the original state. And you can see here that the code still works. It's able to check if the back is blocked. Now, if I say 3, 2, so if I started in a different position and compile and run this time, we should be able to see that it still works and that it doesn't change the state of the robot. So there it is. It's going to turn on, it's going to check, and then it's going to return to its original state. And you can see here that this time it doesn't print that statement from before. Okay? So with our new robot, there's a lot of more interesting things that we can do. We can get it to solve more interesting problems, but we have to be really careful in our work and in our logic. Thank you for